All right, so now we're going to take a look at how we can apply some of those ideas behind measurements that we saw previously to another very important topic that we're going to see in chemistry and in science, which is something known as significant figures. So we're going to be looking at this from the perspective of measurements that are made. And as we've seen previously, every measurement is going to have some degree of uncertainty associated with it. So every measurement has uncertainty, and that uncertainty is dependent upon the instrument that is being used. So when we talk about significant figures, we're looking really at the numbers in the measurement that actually give it meaning. Okay, so for example, in a couple of the ones we looked at before, let's say we measured the length of a piece of steak and we saw that it was 1.3 meters according to the ruler or whatever it is that we're trying to, or that we used. What this suggests then is that this last digit here is my uncertain digit. Okay, we are certain about the 1, it's 1 point something, and the 3 is what is being estimated, which means that it is going to be uncertain. So in this particular measurement, then we can say that this, in terms of significant figures, or sometimes this is referred to as sig figs, or just SF for abbreviations, or sometimes significant digits is another term that you'll see. This would have two significant figures in that measurement, both the 1 and the 3, right? So that's a very simple case to kind of to lead into this. We're going to take a look at some rules for identifying significant figures in measurements, right? So again, any measurement that you make is going to be limited by the instrument that you're using, and we're going to have to make some estimations based on the smallest graduations that you have in that instrument, and what we can actually estimate based on those smallest graduations. So let's take a look at some of the rules for recognizing significant figures. So the first rule is that any digit that is not a 0, so in other words, non-zero digits are always going to be significant. Okay, so for example, if we have a measurement, like we said before, of 1.3 meters, this is going to have two significant figures. If I have 123.97, right, all of those are non-zero digits, so that's going to have 1, 2, 3, 4, 5 significant figures. So it's fairly simple if your number only has non-zero digits. Where the issues arise are with the zeros. Okay, so what about the zeros? Well, let's take a look, first of all, at the simplest case of the zeros. And if that 0 is a 0 between non-zero digits, so we're going to refer to those as sandwiched zeros, or sometimes they're referred to as confined zeros. So these are zeros between non-zero digits. And these are always significant. Okay, so for example, if I have 103 meters, obviously the 1 and 3 are significant. Here, the 0 being a sandwiched 0 is going to be significant. That's going to have 3 significant figures. If I have 1,003 0.03 meters, well, obviously the 1, the 3, and the 3. Now, both of these two zeros here are sandwiched, and this 0 here is sandwiched as well because it's between these two non-zero digits. So I have 1, 2, 3, 4, 5, 6 significant figures in that measurement. Okay, so that's a sandwiched or confined zeros. What about zeros that are at the front of a number, or referred to as leading zeros? So these are not significant. Okay, so again, leading zeros are the zeros at the front of a number. So if I have something like 0.3 meters, well, Obviously, the 3 is significant. There's a 0 at the front. There's no other non-zero digit in front of it. So then this is going to have 1 sig fig. If I have 0.0003 meters, obviously the 3 is significant. Now, all of these are leading zeros. They're at the front of the number. This is still only going to have 1 sig fig. Okay, leading zeros are not significant. All they do here is serve to establish where the decimal place actually is. Okay, so the next one is going to be our trailing zeros. So these are zeros at the end of a number. And there are two scenarios that we're going to encounter, is if that number has a decimal point or if the number doesn't have a decimal point. Okay, so if there's no decimal point in the number, the rule that we're going to follow is those zeros are not significant. And I'll explain why this is here. So for example, if you have 120 meters, right, what we're saying is that our instrument that we're using is allowing us to estimate to the tens place, right? So that's as far as we can go with our particular instrument. Then we're saying that this is going to have 2 significant figures. Okay, similarly, if I have something like 1200 meters, well, now our instrument is only allowing us, based on the graduations, to estimate only to the hundredths place. So this is still going to have 2 significant figures. So that's if there is no decimal point. Now, if there is a decimal point in the number, then the trailing zeros are significant. So if I take the 2 examples above, so if I have 120 and now I put that decimal point there at the end, and this is meters, right? What this is saying now is that I'm actually able to estimate to the ones place using whatever device it is that we're using. So this is going to have 3 significant figures. If for this, the other one, if I have 1200 and then a decimal point at the end, and that's meters, this is also telling me that I can estimate all the way to the ones place. And I'm thinking now it's exactly at the 0 mark. So I can estimate that. This is going to have now 4 significant figures. So the absence or the presence of the decimal point makes a big difference in terms of the precision of the instrument that you're actually using. Similarly, if I have something like 12.00 meters, now again, what this is saying is, because the decimal point is these zeros are still at the end of the number, and this is telling us we're able to estimate to the hundredths place, and this is also going to have 4 significant figures. Okay, so we're going to have to try to identify how many sig figs are in a particular measurement, and again, that is going to be based on the instrument that we're actually using, right? So the significant figures is going to give us an idea of the figures or the numbers or the digits in a measurement that actually have meaning when we make that particular measurement. So when eventually we get into some calculations that involve using significant figures and getting an answer, we're going to have to round those answers to the correct number of significant figures. So let's take a look at how we round. We're going to remind ourselves about rounding. So for example, if I have the following number, I have 137.23619 meters, okay? And if I say I'm going to round this to, let's say, 1, 2, 3, 4, the 5 significant figures. Okay, so based on whatever operation we're doing, we get this number, and then we need to round it to 5 sig figs. So the way that we do this is that we're going to start here on the left side. So start on the left. We're going to work our way across until we get to 5 sig figs. Okay, so obviously now the 1 here is going to be significant. That's my first, my second, third, fourth, and then this is my 5th sig fig. So I can draw a line under these first 5 significant figures, and then, or you can draw a line right after the 5th one. I'm going to take a look at the 6th, the next digit in line, and see if that number is, or if that digit is 5 or above. If that digit is 5 or above, which in this case it is, it's a 6, I'm going to round the last digit that came before it, I'm going to round that up by 1. So this then is going to become 137.24, and then that's going to be meters as my unit in this case. So this is going to have 5 significant figures. Okay, start at the left, work your way across, get to the correct number of sig figs, and look at the next digit. Is it 5 or above? We're going to round the previous digit up by 1, and then just drop the remaining digits, right? Similarly, if we take the same number above, I'm going to round it to 4 significant figures. So I have 137.23619. Okay, and then this is meters again. I'm going to round it to 4 sig figs. So start at the left. So 1, 2, 3, 4. So the 2 there is the 4th sig fig. I look at the next digit. This next digit here is less than 5. So I don't need to round the 2 up by 1. I can keep the 2 as it is. So this becomes 137.2. And I just drop the remaining digits. This has 4 sig figs, and I have meters as my unit. Okay, so if I would now instead round this to, let's say 2 significant figures, right? So I have 137.23619. Okay, again, start at the left, work my way across. So this is the first, this is the second. So I'm going to draw a line right after the 3. Those are my 2 sig figs. Okay, I'm then going to take a look at the next digit. This is it 5 or above? Yes, it's 7. I'm going to round the previous digit up by 1. So this becomes 14. Okay, and because now that we're on the left side of the decimal point, we can't just drop the remaining digits. We have to replace the remaining digits up to that decimal point with a 0. Okay, so 137.23619 is rounded to 140, and that's 2 sig figs, right? So the 1 and the 4 significant. We don't need the decimal point here, right? And the reason is if you put the decimal point, then it makes a 0 significant, right? So this becomes 140 with the 1 and the 4 significant. The 0 at the end being a trailing 0 with a number without a decimal point, that's not significant. This becomes 2 sig figs. Okay. Similarly, if I take that same number and I want to round it to 1 sig fig, okay, so now I have 137.23619 meters. Okay, start at the left. The 1 there is my first sig fig. Draw my line. The next digit, the 3, is less than 5. Okay, so I'm not going to do anything to the 1. I'm going to keep the 1 as it is. And I'm going to replace the remaining digits up until the decimal point with zeros. Then I can drop all the other digits after the decimal point, and then meters is my final unit. Right, so this number has just 1 sig fig because the trailing zeros here are, are not significant, excuse me, because we don't have a decimal point. So this is going to have 1 significant figure. So when you have, eventually you do your calculations down the road, we're going to have to round. Okay, this is just a reminder of how we round a particular number or a measurement to the correct number of significant figures. So we're determining, we're looking at identifying sig figs, and those significant figures are going to be very important in any measured number that you have. And just as for a frame of reference, we can compare measured numbers to what are known as exact numbers. Okay, so measured numbers, which we've been talking about for quite a bit, versus exact. And what's the difference between them? Well, measured numbers, we get those from measurements, as the name suggests. Okay, and because we're getting them from measurements, that means that there's going to be some degree of uncertainty associated with those measurements, right? That's just the nature of making measurements. And comparing that to an exact number, as the name suggests, an exact number is exact. There is no uncertainty associated with an exact number, meaning that we are certain of that measurement. So where do exact numbers come from? Well, if you count something. So let's say, for example, there are 5 eggs in a carton. Well, there's exactly 5 eggs in that carton, right? There's not 5.1 or 3.9 or 4.9 eggs. No, there are exactly 5 eggs in that carton. That's an exact number. We are absolutely certain about that. We don't have to consider sig figs in that measurement. You can think of it as having an unlimited number of significant figures when it comes to exact numbers. We can also get exact numbers from relationships, mathematical relationships specifically. So I'll give you an example. We'll talk more about this next for the next week's content. So relationships, for example, within a system. So for example, in the metric system, which is the system we use in science, we'll see that 1 meter is equal to 100 centimeters. And this is an exact relationship. There isn't 100.1 or 100.01 centimeters in a meter. No, there is exactly 100 centimeters in 1 meter. So again, that's an exact relationship. You can consider that as having an unlimited number of sig figs in terms of calculations and rounding and stuff. That doesn't affect sig figs in your calculations. What will affect your sig figs are your measured numbers and your measured values that will have some uncertainty associated with it because we're using instruments to measure those values. All right, that is just a brief intro to sig figs, recognizing sig figs, the rules for recognizing significant figures in a measurement, and how they compare to exact numbers that we get from these couple different places.